Hey guys. So, as you might have guessed, we're going to be talking about batteries today. I like to make myself notes because I'm the kind of person who goes on tangents when I talk about stuff. And notes help me keep on track and keep my thought process working in the proper direction. I have 5.5 pages worth of notes for this that I wrote up, and I thought I was being real clever and thorough, and then I realized, like, these people don't want to know all that crap. They just want to understand at a basic level how a battery functions and why it does the things that it does and how that interacts with their Saber. So, that being said, I'm just going to let you guys read through these definitions. If you want to, I'm going to basically cover all of them as I talk about a battery and its function in a circuit, and then I'm going to go over 1 page worth of my notes on a few important things when you're selecting and purchasing your batteries for your Sabers. Okay? So let's start out right here with this circuit. This is the same circuit that I showed in the first video, the last video that I made. And the only difference you're seeing here is that I have the battery drawn now in detail to show exactly how it functions, okay? The battery is made up of basically 3 separate parts. It's simplified in this illustration. It doesn't actually look like this on the inside, but you have an anode, which is at your negative terminal. It's connected to the negative terminal. You have a cathode, which is connected to the positive terminal. Cathode and anode are made up of materials that are not the same. They're dissimilar. If they were the same type of material, the battery would not function. And that has to do with the chemical reaction that takes place. A battery takes chemical energy and it turns it into electrical energy. The third part of the battery is the electrolyte. And the electrolyte here is shown in green. And you'll see all these little black and red dots. The black ones are anions and the red ones are cations. And those are ions. Ions are atoms that have a charge, a negative or positive charge. Anions have a negative charge, cations have a positive charge. What you're seeing here is the anions are moving towards the anode because ion flow is occurring, and ion flow is not like current flow. Ions inside of this electrolyte, the anions and the cations, move to a similar charge, not a dissimilar charge. So your current flow is going from your negative terminal to your positive terminal, and it's electrons moving. These ions in here, the negatively charged ones, are moving to the anode, which is negatively charged, and the cations, the positively charged ones, are moving to your cathode, which is positively charged. And that happens because of a chemical reaction due to the circuit being completed. So when you have a complete circuit, your switch is pressed and your connections in the circuit are good. You have current flow due to a chemical reaction that causes cations and anions to move from the electrolyte to the cathode and the anode. And then at the same time, you have electrons that are building up here on this anode. And you have a scarcity of electrons over at this cathode. So the scarcity here causes the cathode to pull the nearest electrons in the circuit. So it's pulling them from the wire here. And as it starts to pull them, you're seeing electrons being pushed away from the negative terminal. And this makes a domino effect in the circuit. So electrons are flowing here, and all of a sudden you have current flowing through this whole circuit. That's basically how a battery works. I'm not going to get into the details of what atoms are and how the chemicals inside the battery work. This is all you really need to know to understand what's happening. Something else that's relevant that was brought up by a couple of people, but it's not super important, is the difference between conventional current and electron flow. So conventional current and electron flow both describe the way that current is moving. Conventional current says that current is moving from positive to negative, but electron flow, which is actually what physically occurs, says that electrons are moving from negative to positive. And the reason I describe it with electrons in electron flow and not in current flow is because the discovery of electrons didn't take place until well after current was being described. So at the time that current was initially defined, it made sense to say that you have a surplus at your positive, and so current moves from the positive to your negative, because that's the way that we think. We think positive means we have more, so it moves to negative, and that's the way they defined it. But then later, when electrons were discovered, they realized that actually electrons are moving from the negative terminal to the positive terminal in your circuit, thus electron flow. And both of them are academically correct because they're both still taught today. But when I talk about current or circuits in these videos, I'm going to be talking about electron flow, and that's what I'm going to use to teach because that's what's actually occurring. When you purchase components or you look at circuit diagrams, a lot of the time you're going to see conventional current, and just know that it doesn't matter what the circuit diagram shows, and it's not relevant to you building your Saber, but be aware of this and be educated on it in case you have a discussion with someone, or in case you're looking at a diagram and you're confused about why it's showing current moving the opposite direction of what you're used to seeing. Okay, so with that out of the way, I'm going to talk a little bit about how you should go about purchasing batteries and the terms that are important when you're purchasing them. And for that, I am going to pull out those notes and go over them a little bit. These notes here are definitions of things that go into more detail than most of you are going to want to know. But if you're interested, pause the video, take a look at them. Also have the diagram of an atom, which when I was in my state of thinking that I needed to tell you guys everything in the world, I started defining a lot of things that had to do with the chemical reaction, and I got a little too into the weeds. So here are terms that are relevant to battery selection and how it affects your Saber function. Make sure those are in screen. All right, so we'll start with typical batteries used in your Sabers. They're going to be lithium ions most of the time. Occasionally you'll see people using AA's, and if they're rechargeable, those are going to be nickel metal hydrides or NIM batteries. And if they're just standard non-rechargeable, those are alkaline batteries. But lithium ions, that's what we're going to be focusing on. So those are lithium-based rechargeable batteries. Lithium-based meaning that they use variants of the element lithium. Shapes and types. The type that we're going to be talking about is cylindrical cells. I'll leave the other ones out, but there are other types of lithium-ion batteries. They come in different sizes. The size most often used in Sabers is going to be 18650. That number just means it has an 18 millimeter diameter. It's 65 millimeters in height. That size will vary a little bit based on the manufacturer and the components that they add to that battery, but it's going to be very close to that size. Most websites that sell these batteries are going to give you a more specific dimension for the batteries. And if the battery has a button head, meaning it has this little button shape on the positive terminal, that's going to make the battery a little bit longer. Not all batteries have button heads, some are just flat. And usually that will be noted in the description of the battery as well. Okay, so back to sizes. There are a lot of sizes in lithium ions and cylindrical cells. I have listed a bunch of them here. 42 120s, 32 900s, 26 650s, 32 600s, you get it. There's a bunch of them. And what you use is going to be based on a couple of things. The larger they are, typically the larger capacity they have for holding charge, and then obviously depending upon the size of your installation space, you're going to be choosing a battery that fits in there. But a lot of the time 18650 is chosen for Saber installs just because it is a good middle range size with a larger capacity in it to run a Saber for a respectable amount of time. Okay, protection circuits. Those are usually a PCB, a printed circuit board, mounted to the battery, and it monitors various conditions of the battery, and it cuts power from the battery to your circuit if it detects any unsafe readings for discharge, charging, short circuits, etc., things like that. Stuff that causes a dangerous situation where the battery might have a meltdown. Terms that you're going to see for ratings on a battery. So when you go to buy a battery from a site, you're going to see milliamp hours voltage, which is actually nominal voltage, and then amps, which is the max continuous discharge current usually. Those things are important because your milliamp hours is the capacity of the battery. It shows a measurement of power over time, how much power is put out over a certain period of time. And milliamp is just 1/1000th of an amp. So milliamp hour is 1/1000th of an amp hour. Voltage. We talked about that before. Potential energy difference between positive and negative terminals. More specifically, though, when you're looking at ratings for batteries, you're looking at nominal voltage. And that is the rating of a battery despite its actual max charge. On a lithium ion, so let's say you're getting an 18650, you're going to see 3.7 volts if it's a single cell. 4.2, though, is the actual max charge, or the charge voltage, and that's what the battery will charge to at full capacity. If you were to take a reading from that battery's positive and negative terminals, you're going to see closer to 4.2 volts at full charge. And then the max continuous discharge current is really an important thing to look at, because when you are purchasing a battery, you need to make sure that it can put out enough current to power your highest or your most current hungry component in your circuit. And the max continuous discharge is just the highest current output that the battery is able to maintain continuously. Okay, so how all of this stuff applies when you're purchasing your battery. The important things to consider, let's start with, you first ask yourself, what do you intend to do with your battery? All right, and here's an 18650. You should know from the conclusions you've drawn from your situation what physical size you need, size for this one being 18650, the voltage that you need, that's your nominal voltage, capacity of the battery, your milliamp hour rating, the max current output in amps, and whether it has a protection circuit or not. So then you need to find your preferred battery and your supplier. It's not difficult to find good ones, but it is very easy to find bad ones. And things to consider here, is the cell that you're looking at high quality? Are the ratings that you're seeing, your capacity, your voltage, your amp output, are they accurate or are they overly exaggerated? Is the cell real or is it counterfeit? And is the seller reputable? Those are all very legitimate things to ask yourself, to ask other people, to make sure you know when you're making a purchase, because you can get burnt. I have been on a couple of occasions. It's been a while because I know what to look for now, and I know reputable sources that test batteries, which I'm going to be sharing in the description below. You can do a lot of research to find out the answers to those questions, but luckily there's a lot of people doing that already. So I'll link some sources to help answer those questions or just to bypass them, so you don't have to work too hard to figure all that out. But keep those things in mind, because not all batteries are created equal, and some, in fact, are just cheap shit. All right, lastly, let's go over safe use of lithium ions. These batteries are notorious for their flammability, typically only when they're exposed to unsafe conditions. So let's do everything possible to avoid those circumstances. Buy them with a protection circuit built in. If you want to put one in yourself, that's fine. But obviously you need to know how to do that. So I just say buy one with a protection circuit. I have put protection circuits on batteries a couple of times, but most of the time you can find the cell you're looking for with a circuit on it already, so there's not much need to do that on a regular basis unless you're providing batteries as a service to other people. If a cell has a protection circuit on it, it's going to say so in the description of the battery, and if that description does not say there's a protection circuit, assume there isn't one. Do not short circuit your batteries, meaning do not connect the negative and positive terminals directly without a load in between them or something to take up the power like an LED. Even if you have a protection circuit built in, it's not a good idea. It's just something you want to stay away from, okay? Build it in a habit in your head to never bring this battery into a circumstance where it's going to be shorted. Don't roll it onto your table when you're not using it and let it touch up against your solder or against a pair of tweezers or spare wire or say a wad of steel wool that you have or something like that. Be mindful of where you're putting your batteries, and that brings me around to storing the batteries. Plastic or non-conductive containers that can hold your batteries. Anything that keeps them separate. And if you put multiple batteries in a container, even if they weren't touching or if they're separated, place the positive terminal with the positive terminal of the other one. That way, if something were to fall into this container that's conductive, it's not going to bridge terminals and create a circuit. Okay, other things. Don't expose them to heat, especially in excess of like 122 degrees Fahrenheit and 50 degrees Celsius. That range is going to vary a little bit, but that's roughly the safe operating temperatures for these batteries, or charging and discharging temperatures. Open flames, no bueno. You don't want open flame on them. That's sort of an obvious given. All right, and then give just as much consideration to your charger and your charging process as you do to the batteries themselves. In other words, use a smart charger, one that can read the state of this battery, and it knows when to start and when to stop charging. I'm going to give links to those along with the other links that I've promised down in the description. Okay, I know this video was long. We're running well over 15 minutes, but there are probably still questions that you have or things that are not making sense to you. If that's the case, please watch the video a couple more times. I know that if this was my first time getting all this information, I would probably need to watch this video 2 or 3 times to grasp all of it. And feel free to ask questions, as always, in the comments below or on the Saber Builders Academy on Facebook. I'm going to link that in the description too. And guys, if you got a project going on right now or you're thinking about starting one, get after it. Stick to it. Have a good week, guys.